What's really important is to get direct feedback on what you're doing. So in sports, it really helps if you get your images or your video feedback right away. It's very important to get data. It's not necessarily about more data, but it's also about getting better quality data. So developing these traditional computer vision algorithms didn't really work out.
Welcome to Inspiring Computing. This podcast is where computing meets the real world. This podcast aims to trigger your curiosity by talking to proficient and advanced users of MATLAB, Python, and Julia, who use these tools to deepen their understanding of the world by simulating it, exploring trade-offs, and gaining insights that help their companies add more value. In addition to proficient users, we will be also talking to product marketing, toolbox authors, package developers, and library maintainers to see what drives the development and what issues they are solving for others to benefit from. In this episode of Inspiring Computing, we talk to a proficient user of Python, Kun. He is so proficient that he ended up creating a company that focuses on computer vision algorithms. More concretely, he uses deep learning to parse video feeds from local sports clubs to get analytics to improve gameplay and strategies for players. In addition to this, he also broadcasted to partners and has set up an entire workflow which enables him and his team to be very effective and efficient in fault finding, testing, and analyzing different types of data from multiple camera feeds. Welcome, Kun, to Inspiring Computing. It's been a while since I've been trying to get you on the podcast. I'm glad you can make it.
Yeah, thanks for having me, Gareth. I'm really looking forward to this.
I noticed you have a very cool and inspiring company called Eyedle. I know we're going to be talking a little bit about your company and a bit of your background, but before we do that, can you tell us a little bit of who you are and maybe how did you get started in programming?
Yeah, so I'm Koen. I'm a co-founder of Eyedle. Did my master's in data science and entrepreneurship at JETS in Sertogenbosch. And basically how I got started in programming, that was also in university. So I'd never done it before. And they just threw me into the deep end. And I had no clue what I was doing. So I messed around with programming for a couple of years before I actually got a hold of it. So it was pretty intense, but I needed it to complete my studies, basically. And in the end, I learned to love it.
Many of us learn programming like that. And when you say programming, I'm assuming your first language, was it Python? Is that what you started with?
No, we started out with Java. So that was mandatory in university. And I had a hard time grasping all the concepts there. And then when I got to my master's degree, we switched to Python and it felt way more intuitive for me. And it was easier to get done, basically.
And then it was so easy that you then ended up creating this company called Eyedle. So I've done a bit of research about it, but tell me what it actually does and what you guys do.
At Eyedle, we automatically record sports matches and we write the software to enable this. Sports clubs or teams come to us. They ask us for a recording solution and we basically help them get everything together. So we go to the club, we install the pole, we put a server there with the GPU and we make sure that there are some cameras around the field. And all of this combined will help us in recording the match. So when every hardware piece is set up, we install the software and the software allows us to automatically record all matches that they have, but also trainings. So basically to automate that whole process.
So I've got 1,000 questions all of a sudden. So this is super cool. Is it for tennis? Is it football? Is it hockey? What types of sports are we looking at?
Yeah, so it's mostly team sports right now. We're doing field hockey. We're doing soccer, korfbal, which is a typical Dutch sport. It's a bit related to basketball. And we're also going to do a pilot in basketball in the coming months. So that's a very exciting sport as well.
So you go to a club. So I'm assuming this is not super professional clubs. You started maybe the amateur, maybe up to middle-sized kind of clubs. And you say, hey, we'll put one camera or multiple cameras at the side of a pitch. And then you record this. And then you give insights to the coaches / players to improve their game and training. Is that it?
Yeah, that's basically it. The area that we really focus in is the clubs that are in the sub-top. So the real top club, PSV over here in Eindhoven, all those matches get recorded. So that's less interesting for us. But all the clubs that are good and want to improve their game, but don't have the recordings basically, those are interesting for us. So both for purposes of training and for recording matches. And then basically the purpose is twofold. So on the one hand, we can actually help those players and teams improve their game. But on the other hand, we can help the clubs to actually broadcast footage from their teams and get some more online traction for those clubs.
Okay. And when you're broadcasting it, so, when you see the World Cup and things like that, you see these statistics of players appearing and you see these number of corners, free kicks, yellow cards, and so forth. Do you do something similar for those teams?
So on a very basic level, we do. So what we've noticed is that it's really hard to create a good business model around it for these sub-top clubs, but we actually do classification on the images that we collect, and the classifications help us to determine what kind of actions are being played on the field. For example, for field hockey, we are able to recognize the penalty corners. And for soccer, we're working on penalty classifications and also corner classifications to actually get those game situations in picture in a perfect way.
If we go into a little bit more of the technical details, so if I understood correctly, you install one camera. It's not like you have 15 cameras around a field.
It really depends. So for the clubs with a little bit less budget, we are able to actually install 1 or 2 or 3 cameras. Doesn't really matter. And with those cameras, we can easily record the match. So those are static cameras. They don't really move or do anything interesting. They just record the match. And a typical setup is composed out of a pole with 2 cameras on it. So we film the left part of the pitch and the right part. Then if a club has more budget, we can actually do something cool and something interesting there. We can install a PTZ camera, which stands for pan, tilt, zoom. And it basically means that the camera can move in any direction and also is able to zoom in an optical way, which is very nice because when zooming optical, you also retain the quality of the image. And with these PTZ cameras, we're actually able to get a really interesting recording of this match, which is way more attractive to look at. So it has a very high quality, and it really helps to analyze the games, but also helps to make it more interesting for broadcasting.
You said earlier you do classifications. Walk me through this. So this means that you've got these video feeds, so one or multiple video feeds. You said you also install a GPU, a server near the field, near the pitch. So I'm assuming you have these live streams coming in, and then you said classifying corner kicks and things like that. Walk me through, what does that exactly mean, and how do you do that?
On the pitches that we actually do these kinds of classifications, we've got a setup with a camera pointing to the left part of the field and a camera pointing to the right part of the field. And both of these cameras are recording continuously. So when there's a match, they basically fire up and the GPU also fires up, and the stream of images coming from left and right is passed through the GPU. And on these GPU, we are running deep learning networks for classification. The GPU it might be interesting to know, NVIDIA 3060 Ti. Basically, we're able to use that GPU to process a lot of images real fast and also keep them at quite a big scale, which is very useful as we do not have to resize all of the images down to a very small image. And that really helps us to find the details that we're looking for. And once we've processed these different images, we actually have a classification on whether something is a penalty corner or not, or a corner or a penalty kick. But that's not just it. So you also get a lot of false positives, which doesn't really help you. When you get a false positive and you start aiming your camera at that false positive, you're really screwed because the action could also be happening on the other side of the pitch. So it's very important to also filter out those false positives. For that, we've also attached some different blocks to our pipeline in which we do all these image processing. And this block actually is able to filter really well when these penalty kicks are for real or when they're not. So we're using object detection as well. So we're able to not only classify, but also detect different objects on the pitch, for example, the ball or the players. And using this information, we're also able to filter out falsely classified events.
So you are receiving these video feeds, right? And then you run the video feeds through some software. So I'm assuming, is this where the Python comes into play? And then you create a pipeline, which is is it like an algorithm where you say, okay, first detect the ball, then second I need to detect the field, or then classify it, then measure it between 2 frames, and you get the speed information? Is that what's happening in the background, or am I off here?
Yeah, in a way, that's what's happening in the background. So all of these images that are coming out of the camera, they're being thrown in this pipeline, and the whole pipeline is basically Python. At the start of the pipeline, we ingest all of these images, and this pipeline basically consists of different blocks. We ingest all of these images, and it goes through the first block. That's the block of pre-processing. And in this pre-processing step, we already resize the images to the size that we need. And when we get past this pre-processing step, we also do some additional filtering and alignment of different frames. So you can imagine that these cameras are not perfectly able to record in parallel. So there's also always a bit of time between the 2 frames from left and right. But we do need to pair them up together in order to make sure that all the detections are happening on frames that have a similar timestamp. So otherwise you could get a very large discrepancy between different times or between different images. So they could be a second apart. If you then start to do all of these detections for left and right, there could be some overlap in detections, which isn't really beneficial for tracking the whole play. So we do an alignment. Then when we get these packages of 2 images, we do some detections and some classifications. And after these detections and classifications, we do the filtering step. And then once we have the filtering step, we are actually able to implement some logic that actually steers the camera into the right direction. So it's a whole bunch of steps to actually get to moving a camera.
And is this 100% Python based, or are you like integrating a whole bunch of languages? So you called out GPU. Did you use any specific packages, or walk me through that decision of why Python in general for your company?
Yeah. So most of the stuff that we have developed is actually in Python, but under the hood, there's also some C running. So we're using a framework for doing all of the detections. That's called Darknet. It's a pretty well-known framework. If you're familiar with YOLO detections, YOLO networks, it should ring a bell because those are mainly developed in Darknet as well. And that, under the hood, that's using C. So that really helps us out. And in between there's also some smart bash scripts running, but those are just very small and basically helping us to facilitate running the whole process. But most of the stuff is Python.
You called out the classification and the detection stuff. I'm assuming there's quite a lot there. So make it sound like it's easy, but I remember back in my day or even when I first understood that an image is a matrix, a 3D, and that has a huge impact if a ball is close or far. The number of pixels it represents, there's usually calibration around it. There's a whole bunch of steps around this to make accurate assessments of this. And if you put that on top of resizing images and maybe the images are moving or not, there must be quite a lot of work there around the computer vision side of things. And I'm assuming it depends per sport, per field, because fields I think also change, if I'm not mistaken. Not all fields are the same dimensions. How do you go about this? It sounds like a minefield full of problems. How do you train your models for different scenarios? You must have, I don't know. For hockey, you have certain models, basketball, others, and so forth. Walk me through how you deal with all these variations.
So the variations make it hard, but also interesting. So there are a couple of things that are very similar in almost all sports, and that's that the pitch is square. That really helps us already. Makes it a bit easier because we use the dimensions of the pitch. We know them beforehand. We put them in a configuration file. And because we know the dimensions of the pitch and we know where the camera is installed, we're actually able to start doing some smart calculations on where people are in the frames and in the pictures. We can translate those image coordinates basically to world coordinates. So that really helps us to pinpoint all of the locations of the individual players as well. So we don't just detect the players out of the images, but we're also able to relate that to what's happening in the real world. So that took some effort to actually get right because it involves a lot of trigonometry. So that's one part, but we had to do a lot of different things with the images. What's interesting is that we actually started out with not doing computer vision as we do it today. So right now we're using a lot of deep learning models, but to start out, we actually used some standard computer vision techniques. So basically a lot of thresholding, a lot of subtraction between foreground and background, some smart techniques that we thought would be useful in detecting the ball. But it turned out that it was too hard to do. What you often see is that deep learning works pretty well in an environment that's very variable. So when there's a lot of basically noise or different things happening and going on. But in, for example, factories, this is not the case. So it's a very standardized way of working there. And when we started out, we thought it was a very good idea to actually borrow from that domain and actually use computer vision algorithms that are really fast and very accurate. But we soon found out that this accuracy was not, it didn't really translate to the real world or the world of sports, basically. So we're dealing with a lot of different light conditions, a lot of different colors. So the pitch can be green, but in some sports it can switch to blue as well. So for field hockey, you've got blue pitches, you've got green pitches. They play with white balls, orange balls. Everybody wears white shirts, white shoes, orange shoes, everything. It's really a big mess of colors and different things. So developing these traditional computer vision algorithms didn't really work out. So we quickly found out that was not an option. And then we switched to deep learning, in which we're better able to capture all of the information and get some useful insights out of that. But there are a lot of different things and a lot of different holes in the road to actually get to a solution that really works and works well.
I'm assuming that before every game or match, it's not that somebody from your company has to go out and recalibrate things. You've made this self-sufficient, right? So
Yeah.
You go there, you install it once, and you say, "Don't worry, life is good. All trainings, games, we got you covered," kind of thing. Is that how it works?
Exactly. So that's how we hope that it works, but in reality, it's not always the case. So as I mentioned earlier, we're using a configuration file, and that configuration file, among others, includes the dimensions of the pitch, but also a whole lot of other different parameters. So for example, the IP addresses of all the cameras, of the server. This configuration also includes what models we want to run, in what order we want to do it, what types of things we want to filter out.
Do you upgrade like halfway through? So you say, okay, now that we're getting all these video feeds and we've got, instead of 10 hockey fields, now we've got 20 hockey fields. I'm assuming you take those 20 hockey field videos, you retrain your models, and then do you deploy it back to all the other 20 locations?
Yeah, we do. So we are trying to continuously improve on all the models. And what's really nice to see is that it's actually working. So it's very important to get the data right. So it's not necessarily about more data, but it's also about getting better quality data. We've got a couple of data sets, and the data set that we started out with was very noisy. And the data that we used for ball tracking or finding the ball, that was not that good. What you actually want is very consistent, very pretty, and evenly labeled data. But it turned out that we didn't really have that. So we saw a lot of false positives, a lot of false negatives, detections all over the pitch. But then in the end, it turned out that the tool that we were using to do our annotations also did some interpolation. How you can imagine it to be is like this. So you've got a video, you throw it into your annotation tool. And if you've got a smart annotation tool, you can annotate a frame, skip 10 frames, and do another annotation. And then all of the annotations in between are being interpolated. This is really nice because it really helps you to speed up your process of doing the annotations. But we've got a small issue there because the ball is traveling at such high speeds and also not at a linear speed. So it accelerates real fast, it decelerates real fast. These interpolations do not add up. So all of the frames that are in between these points that we skipped, they're all off. So basically if you tag a frame or number 1, then tag a frame number 10, all of the other 9 in between, they're bad. Basically, we didn't realize that at first. We thought it was all really nice. You don't really see it if you're zoomed out, but when we zoomed in, we actually saw that there was a lot of poor annotations in there. So we're currently working to get those out as well.
So how do you do that? You said you use Python. So are there any specific Python packages you're using? Is this pure Python?
Yeah, so we're not doing the annotations in Python itself. So we've got an annotation tool. It's called CVAT. CVAT, and that's an open source tool in which it's really easy to do your annotations and also to export it to different dataset types. We had a horrible experience with OpenCV. It's really easy to use unless you want to use the GPU. We're using this darknet framework, or basically the models come out of darknet and they have an extension called .weight. And you are actually able to load those in using the CV2 DNN package. And that's actually able to also utilize your GPU. But when you actually want to do that and utilize your GPU, you have to build it from source. And we're working with all of these different servers that are in different locations. And it really becomes a pain to actually manage all of that packaging and getting all those servers running correctly. So we've Dockerized the whole thing, made a nice file for that. And right now we're able to relatively easy deploy everything. But in the beginning, it really was a pain to actually get OpenCV using our GPU. And you still need to have a lot of different software components in place to actually be able to do that. So there's like a whole recipe for deploying it properly.
How do you set up your work?
Yeah, there are a couple of things that we do. When we started out, it was all kind of monolithic and it didn't really work, right? So everything was spaghetti code. So we did a very big refactor and we created a package for ourselves to use. And this package basically is able to build a whole pipeline for us just based on configuration files. So right now we've got the pipeline repo, and below that is the actual implementation of this pipeline. So we've got a sports pipeline, so to say. And in this sports pipeline, we've got a bunch of different configuration files for different sports. And all of these configuration files, are basically maintained in this main branch, so that they can't be changed. And when we want to do some experiments, we create a new branch and start working on that. And when these configurations are good and the new features that have been implemented also pass the pull request, they get merged back into the master. That's basically the repo that we have for sports.
How do you actually end up testing this?
Yeah, testing was interesting for us. So it's not just functions, it's also working with hardware, and that makes it interesting. So we do have a lot of PyTest functions to actually test everything as we push it or as we want to merge it to master. So that's already really helpful. So that makes sure that the relatively simple things don't break. But we also need to know the performance of the images that we basically record. And that's really interesting because how do you define what a good recording is? So do you need to have the ball in picture all the time? That's a relatively good metric. But if your camera shakes all the way while still having that ball in view, it's not really a nice viewing experience. So we've defined a whole set of rules to actually make this measurable. And we're able to, I want to call it a digital twin, but that feels like a buzzword for it. We are able to run a simulation of the camera when it's not in a live setting. So we can put a camera in the office, just throw some MP4 files at it, and it starts moving, basically. So it thinks it's recording a match. And then we're able to read out the position that the camera has and then reconstruct, basically using each viewing angle horizontally and vertically. We're able to deconstruct whether it has the ball in view and whether the players are in view and stuff like that. So setting that whole thing up was a painful process as well. Learned a lot of different things there. But this is it's very important for validation of your work. So right now we're able to quantify if a change actually makes a difference or whether it just makes it really bad.
So it feels like you probably put a lot of work and effort into not only like the hardware, but the whole infrastructure to make your iterations quicker and better and iterate towards the right direction. So it feels like in the name of your business is actually, it's just as valuable, if not more so, to have a good mechanism that even if out of the gates it's not so good, as time progresses, you will continuously get better, and then it becomes a waiting game. But you need to put a lot of effort into that back-end infrastructure, which doesn't necessarily need yield results the next day.
Yeah, exactly. So it's really preventing technical debt there. So we've actually implemented our whole logging module all by ourselves that is actually able to log everything with timestamps and the whole shebang for every operation that we do on a pitch, and we're able to review those logs after a match. We can automatically process them. We can visualize them as well, because visualizing is a very important part of our work. So we can actually take the images that we recorded and plot all the detections over them. We're able to do that within a couple of minutes after a match. So that's really valuable. And we actually went to PyData last year to the conference, and we had a really interesting talk on that. So Jelmer gave that talk about the logging module that we built, and it's still relevant today. So that's a really nice one. But we've also implemented a whole lot of monitoring. So we're dealing with a lot of different hardware tools or hardware components. So we've got cameras, switches, routers, servers, a lot of different cables between those devices. And we actually need to monitor if all of those things are up and running, because if they're not, our application failed, or at least that's how it feels for our end customer. Right. So we are able to deal with those situations, but then the customer misses the left part of the image, something like that. Or the whole feed is excluded, or the whole thing just doesn't start up. And that's really painful. So we build a monitoring tool as well to actually keep an eye on all the components that are at the different clubs. We spend a lot of time to actually make it foolproof, basically. So right now we get a check on the devices a couple of times per hour. When they fail, we get notified through Sentry, which is really nice for error logging. And we are able to notify whoever is responsible for the recordings at that club. And it really makes our life easy, and it really gives us an edge on communication as well. So we're able to communicate clearly and also very timely when something fails. And when that's during the week, we can actually do something about it. But most of the time, people find out by themselves when it's too late. So to prevent that, we've built in some monitoring.
So you said you use Sentry. So is that kind of like over the weekend, something fails and some customer, then in the Monday morning, there's 20 issues that automatically open and all the development team has to go frantically and figure out, okay, let's debug and see the configuration.
Most of them are really, really easy. So it's just this hardware just didn't respond one time, but after an hour, it went back up. And most of the time that happens during night. I know some power glitch, whatever. But most of the time the issues fix themselves. We're also able to automatically and remotely restart stuff. So if something fails, we can just restart it, without looking at it, basically. So that really saves us a lot of time and a lot of work at night.
So you started off in Java. You said, okay, I don't understand Java, find it hard, learned how to program Python, saw that with Python you could do analytics on sports. And then you said, okay, I'm going to put a couple of cameras on every football pitch, and I'm going to stream the video. I'm going to figure out exactly where the ball is at any point in time, classify people, derive insights, and how hard can it be? Because on professional TV, everyone likes that. And you said, okay, I'm assuming sub-professional, or I don't know if it's tier 1 or tier 2 teams or clubs, they would like something the same. And you set out to do that. But when people use your tools or your products, so you said there's the broadcasting, but also making the teams better, what do actually people see? Is this kind of like a metric of saying for penalties that player X 9 times out of 10 puts the ball in the left corner and that helps the goalkeeper be better prepared? Is that kind of what you're referring to when it helps training? Or are you more like creating snippets just before they kick the ball so that the coach can analyze movements of the arms, the body to say, oh, notice that when you kick, you've got to take a giveaway, a bit like maybe poker, or I don't know, maybe I'm being a bit too creative here, but what kind of things are you looking out for to help players become better?
Yeah, so what's really important is to get direct feedback on what you're doing. So in sports, it really helps if you get your images or your video feedback right away. So it's most important that we actually are able to serve all of the recorded information. It's important that we get that information to the coaches and to the players as soon as possible. And to do that, we basically have two options. So the first option is that we stream it to one of our partners. And when I say partners, a video analysis tool. So a very good partner of us is Team TV, and we stream a lot of our videos over there, and they pick up everything after that. So we basically provide the footage only, and in Team TV you can do your annotations. So they basically allow you to say whether a penalty kick was very well or poor, or they're able to actually fish out all of these different key points and help players improve on that. So that's one thing. That's basically doing the annotations afterwards and getting your feedback on that and try to improve your game in that way. But it's also possible to get a live replay of what you're doing. When you're on premise, we're also able to provide you with your footage right away. And we don't really have to upload it to the cloud first or to our partners. And then you get a live feedback loop of what you're doing. A very nice example, we're not really in that sport yet, but it's gymnastics. So they have a lot of different exercises, and it's really about getting in touch with your body as well. So you're doing all these different gymnastic exercises. Sometimes they look good, sometimes they look bad. And it's very important to relate that to the feeling that your body has when you actually perform those exercises. And the same thing holds for making a great penalty kick or having a kick-ass penalty corner. So it's really important to get that feedback fast, and we're able to provide those images to the players and the team as well.
Yeah, so I recognize this. So back in the day when I was younger, I was playing tennis. I wouldn't say professionally, but I was very enthusiastic. And I remember my coach, what he would do is every couple of months, he would bring out his camera and he'd put it on a tripod and he would position it, and then he would do drills, right? So let's say forehand or backhand or serves. And then he would ask us to do 5 or 6 drills time after time. But it wasn't very active in the game, because in the game it was always difficult for him to catch us and follow us because his recording skills were terrible. But even when we did the drills, what he would do is he would do the whole class or the whole group of us. And then later that night, he would call out and say, let's go through the video. So at this stage, we're like, oh man, I'm tired. I've been running for a couple of hours. I don't want to do it. And then when he was super enthusiastic about it, he would pinpoint saying, look how you're bending your knees too much. But I always had this feeling, it's like, yeah, but when I'm doing a drill, I know I have to do this. So I'm preparing myself for it. It's not exactly the exact same behavior in a game. And that was just the tennis, which is one person on one pitch, one ball, high color contrast, everything is well defined. So I'm assuming that this is what you're really tackling, right? Because it's on site, you can actually get the results very quickly. So you do a drill and then you can call the whole team to a huddle or something and say, check it out. Is that what happens?
Yeah, for example, so when training, this is exactly what you can do. You can just start the recording, and when something interesting happens, you get everybody together, they huddle up, and then you discuss the moment. In a game, that's a bit hard to do. You need a timeout.
So I think this is super cool, and the combination of sports with technology is great. And then you also called out that in your whole platform that it's not only for on the spot, but you also open up your API so that you could enable other partners to connect. So that's when you said broadcasting, you're effectively saying, well, we can push out our video feeds to anybody. And then if there's dedicated teams which go very deep in a specific domain that you haven't had the time to do, you enable them to also provide insights. And then that's a fruitful collaboration.
So we provide crystal clear footage in order for them to actually do their annotations better. and give more insights and more value back to the team.
All of this maths and processing, this is happening locally, right? It's not that you upload everything to the cloud and then you post-process it on the cloud and send it back.
In most cases, we actually do the computing on edge. We've got a server at the club. There's no cloud involvement, so to say. And we do that to actually cut out the latency. So when we have to send it to AWS, do some processing there and send it back, we're losing time basically. And when we can do it on premise, we're way faster in getting the information that we need faster. And because we are that fast in doing these calculations, we're able to actually use or move this PTZ camera all around the pitch. And this is something that really distinguishes us from our competitors. They are not able to do it. So they do all the processing either afterwards or they do it live on a very low resolution of we call it a stitched image. So that's basically a panoramic image from which they crop out a part. And it's a really different solution. So the image quality is way less.
You make it sound simple, and it seems like you've gone through a couple of hurdles to get to where you are today. But is there like a war story that you could share which was caught you completely off guard?
I think we've had two very hard learnings. So the first is actually hardware related, not really software related. We had an installation in Belgium for a hockey club. Field hockey club, and we were really developing on that setup there. So we're based in Eindhoven, and from Eindhoven we started to control the camera, do some tests, some experiments, and everything looked good. And then on match day, everything went to basically. So nothing worked. The camera looked into the wrong direction. It wasn't responding. It completely messed up. So that was a very painful experience. And we didn't really know why. So over the course of a couple of months, we actually started to improve our software, reduce latency even more, really optimize everything in our whole solution to make sure that this thing would not happen again. But it happened time and again, and we couldn't figure out why. So at one point, someone said, we need to get that camera over here into our office. And that was really useful because when we got the camera into our office, we saw that it was actually not responding to the commands. It didn't really send the accurate locations back, and a whole bunch of other issues became apparent. So from having that piece of hardware on site, in our office, we were actually able to do our debugging and development way faster. And we actually thought that the bugs were located or were coming from our software, but they were actually embedded into this hardware piece. But it was very good learning. So for every piece of hardware that we use, we want to get it on site first. And we want to test it, validate it, make sure that everything works as it's supposed to. So that's the first learning, get your hardware on site. And then the second one is basically to check the inputs and outputs of your deep learning models. We are working with a lot of sports imagery, and for field hockey, that's the sport that we started out with. We have a whole data set filled with locations of balls and stuff like that. And this all looks nice until you start training, because your models have a very hard time to actually find this ball. And it took us a very long time to actually realize that we couldn't learn because there were no balls in the images that we put in. And it sounds very strange, but it works as follows. So when deep learning, you oftentimes resize your input images in order to make them smaller, and having smaller images allows you to learn faster. If you cut down your image size by half, you basically get a speed up of 4, something like that. So that really helps in improving your training times. But when you reduce this image size, you lose information. And what we didn't realize at the time was that this ball that we're trying to train on is when it's 80 meters away and you're filming in HD, it's about 3 by 3 pixels. Yeah, it's a surface of 3 by 3. And that's not a lot. So when you start resizing this, when you downsize it by a factor 2 or even by a factor 4, this ball starts to become invisible. It just disappears out of your image because it's so small. It's just a white dot, and when you resize, it disappears. So then, when you throw it into your deep neural network, it's not able to find the ball anymore. And also, the labels that you had or the annotated images, they don't fully correspond to what you were thinking that they were. And all of a sudden, your model doesn't really generalize. It doesn't detect anything. It only finds false positives. And it seems to detect when a player is hitting the ball with his stick, but then it's basically detecting the points of the sticks. So when we check the inputs and outputs during the training sessions, we actually saw that the inputs after resizing were so small that the balls were invisible. So this is something that we'll never do again. We always check the inputs and the outputs of the model.
How do you deal with weather? So in the Netherlands, the sun comes and goes and weather changes quickly. Do you also train for that in your deep learning models?
Yeah, so weather is a really important factor. So we've also got a club or an installation in England, and it's raining all the time there. So we actually need to be able to also cope with these different weather conditions, but also at night, right? So a lot of sports teams actually train during the evenings or really late on the day. It's pitch black, and you've only got these big LED lights shining onto the field. To the human eye, it doesn't really look very different, but when you're doing computer vision and deep learning, it's a totally different scene. So what we actually do is we gather a very diverse set of images, a diverse set of videos and fragments, and we all throw this into our data set. We try to balance out these different weather conditions, and that really helps us to be able to cope with most of them. But sometimes, so for example, when there's snow on the pitch, that's something that's hard to orchestrate. So that doesn't really happen very often, and when it happens, most of the times people don't play. But when they do play, they clean up the pitch. There's a lot of snow around the edges, and you do actually want to take that into account and get it into your data set as well. But we do actually need a lot of data from different weather conditions, also different teams. So you can imagine that we've got a fixed installation somewhere, and all the home players are wearing blue all the time. But this is something in which there's some bias at times if you only train for one club. But luckily we can actually train on different shirt colors. But this is also something to take into account. Yeah, definitely.
When it's like very windy, your poles, they're stuck in the ground. I'm assuming with the wind, they must move a little bit.
Yeah, so there are different types of poles as well. I didn't expect to learn anything about that in my years, but I know a lot of different poles right now, and we're using good ones. So they're very solid. They don't tend to move very much when it's windy. But sometimes we get to clubs and they already have they already had an installation and they already had poles. And they want to reuse those poles. We're a bit reluctant about doing that because they actually start to wave around when it's very windy. Because the cameras that we install are also a bit heavy. When you put them all at the top, the pole starts to swing a bit. But as you mentioned, the easy solution is to actually use some software stabilization to actually get some nice footage out there. So when you want to have nice, clean footage, you can do that trick with the optical stabilization or with the software stabilization. But when you want to have a big overview of the pitch and all the players that are on it, you can't do that because you have to crop the whole image again. And then you lose a lot of information. For technical analysis, this is something that we don't do.
So when creating a company and you're trying to sell it, there's often some kind of thing that makes you special, right? So in your case, I see that you've done a lot of things, but if you were to zoom in or choose one thing that would make you special or stand out, what is that actually?
Yeah, we've got a couple of competitors, and those are all able to record sports matches nicely. But they use a solution in which they stitch images together. From these images, they crop a piece out of that image and they broadcast that. And that's nice and it's easy for processing, but it really decreases the quality of the images that you send out. And what really sets us apart from the competition is that we're using a PTZ camera, which is able to zoom in, zoom out. And because of that, we're not losing any image quality. The cameras that we use are full HD and 4K. And when we zoom, we actually do not lose quality. So we're able to get a really sharp image, very crisp and very clear image in 4K. And that really sets us apart from the rest in terms of image quality. And that's really something that's really, I think, for larger clubs as well. So it makes it more accessible to the whole broadcasting scene. The ability to actually zoom in without the loss of quality, it also really makes the game more engaging. It really captures the emotion of the players as well. And you're actually able to see what's happening near the goal. So the goal is 50, 60, 70 meters away. It really depends on the field.
You need to get good data. So you call that checking your data inputs and your data outputs to make sure that you're in a good place. But I'm assuming you need to get as many clubs in play as possible. That also lends itself to other challenges because typically clubs probably play all at the same time. So instead of looking at 5 clubs, if you look at 200 clubs and by definition they all play on the weekend, your workload over the weekend probably changes as well as your infrastructure and thought process.
So that's a really interesting one as well. What we've experienced is that in the beginning we did a lot of live updates. So we saw that something broke, we fixed it immediately and we pushed it to master. And in the beginning that was fine because not that many people were using our solution. But right now when we do stuff like that, there's a possibility that everything breaks down. So we also decided not to push anything to master on Thursday and on Fridays, because then you're going to be stuck the whole weekend debugging everything and picking up all the garbage.
So ballpark figure, how many terabytes or petabytes do you record per weekend? Do you have a number like that?
So at one club, they record a terabyte or 2 a day during the weekends when they play the most matches. It also depends on the solution. So We've got a club in Belgium. There they have, I think, 7 cameras, something like that. So that's a lot of footage. That grows really fast. And then also in The Hague, they use about 10 to 15 cameras. So they fill up their storage really fast as well. We also automatically delete some of the stuff that's on the server.
But now, instead of looking at a bit of what went wrong and how you got to where you are, I'm curious to know, so what's coming next? And you must have like a roadmap. How do you kind of plan that out? What do you think about it? Is it based on revenue decisions? Is it on specific sports? How do you plan out the future of your company? And maybe more concretely, how does that impact your programming team?
Yeah, exactly. So we've set a couple of goals for ourselves. So we do want to actually serve a decent amount of clubs, right? So we need to actually find different clubs and get them to use our solution. And for that, we basically need to be out there more. So we've been talking a lot about programming today and about what we did with the computer vision and stuff like that. But we also have to do the sales part. So over the coming months, I'm going to be involved in sales way more. So that's going to be an interesting challenge for me as well, because I like to actually dive deep into my laptop, get my head in the code and work out everything. But that just doesn't sell more software for us. So it's a completely different thing to do. But when looking at the programming side of things, so we're also looking into different features that we can implement to actually make the product more attractive. So I've been talking about the live replays that we're able to do. So that's a feature that we just developed last month. So that's a really new one. It's really nice and also very valuable for the teams and the players. We're also actively looking into detecting more events. Right now, we're detecting and classifying all the events that are really relevant for steering this PTZ camera. But we've got a whole framework that's actually able to detect all kinds of events. And all of this event data is very useful, basically. So if we're able to extract a lot of information out of these images, we can do a lot of cool things. So we can start to do highlight generation. We can start to actually quantify how a game plays out and stuff like that. So yeah, we're starting to collect more data on all of these different games. And that's something that's very interesting for now, but also for in the future, because when you get more data, you can also be of more added value to your customers. Right. You can help them take the next steps as well.
I think it's a common pitfall, especially for very smart and talented programmers, that you want to just keep going deeper and doing more and more of the cool stuff. But there's always another side of the business, which is, okay, so we need to fund this, and what are actually people looking for, right? How did you actually get started, in the sense was, you said you started off with hockey, but was this because you were a hockey player and you were like, I wish I could become a better hockey player? How did this whole thing actually get started?
So that's a whole story on its own. I did used to play hockey. I played it, I think, for about a month. And then I actually realized that I didn't really like hockey or team sports at all. So I also played soccer. Also didn't like that. So I ended up playing tennis. But how I ended up starting this company, as I said, I studied data science and entrepreneurship at JETS in Sertogenbos. And there's really stimulated to, be entrepreneurial or entrepreneurial, start your own company or do some interesting stuff within a larger company. And straight out of college, I actually started a company together with Jelmer, and we did some consultancy gigs. It was very interesting. And then we stumbled upon this company called Team TV, which is now our biggest client. And they actually wanted a solution for capturing hockey games automatically. And we were fresh out of university, and we said, oh yeah, we can do that. We have experience in computer vision. So Jelmer he made some models to generate descriptions for clothing. So when you buy your clothes on a website, he was able to actually get a nice description out of that. So for example, you're wearing a nice yellow dress right now. You could have said, that's a nice dress with some flowers, very nice for in the summer, something like that. So we had some computer vision experience, and I graduated on segmenting tissues in MRI images at the Erasmus Medical Center in Rotterdam. So I also thought I was very smart and I knew a lot about computer vision. So we happily said yes to this challenge of filming these hockey matches automatically. And we thought we would be able to do that in about 100, 200 hours. And right now, I think we're 2.5 years. 3 years later, we still haven't completed the assignment, so to say. But a lot of different interesting things have come along since then. So we've greatly improved the solution. And we've actually, instead of just building an algorithm, we've built the whole application and the whole infrastructure. And we built a whole company around it, basically.
What's actually the most fun part of your job? So when you wake up, what puts the biggest smile on your face?
So I think it's not just one thing. It's the many things that we have to do, or that I have to do. 1 hour I'm programming. The next hour I'm talking to clients. In the afternoon, I have to go to The Hague to actually check out on an installation that we did. So really the variety of work that we have is very interesting. So we never have, the same day basically. So that's what I really love.
And if I was to ask you, like when you program Python, what's your IDE?
I'm using PyCharm at the moment. I'm very happy about it.
Okay.
Really easy to use. There are a ton of features, of which I think I only use 5% of them.
Just like everybody else in the world.
Yes, probably like everybody else in the world. Yeah.
How can people reach out to you?
You can find me on LinkedIn. Just send me a message and I'll be very quick to respond.
I saw on your LinkedIn profile, that's also how we got connected. But you do a whole bunch of other things, right? So we've spoke a lot about the company, but there's more to you than just what you do as a company in the sport. So do you want to give a quick shout out to some of these cool other things that you're involved in?
Yeah, definitely. As you said, I'm involved in a lot of different things. One of those things which I really like is PyData. And with PyData, we do a lot of cool things. We host a lot of events. We make sure that knowledge gets shared, just as in your podcast. And this is something which is very dear to me. So I really like to share my knowledge, share all the things that I do, help people prevent from making the same mistakes. So I think that's the main one which deserves a shout out right now.
This is a great place to end this episode. I hope you found it interesting and it triggered your curiosity in some shape or form, at least enough to have a conversation with some friends and family about some cool, interesting insight of how MATLAB, Python, or Julia are actually used in the real world. If they do find it interesting, don't forget to tell them to subscribe to this podcast